What's up, y'all? This is Mr. Walker here, coming to you with our notes for today. And the theme of what we've been doing so far, we are dealing with this time proving that the lines are parallel based off of our angles. Before we were doing the angles were congruent based off of our lines being parallel. This time we're going in the reverse. So let's get our first one. So the converse of our alternate interior angles theorem states if two lines and a transversal form alternate interior angles that are congruent, then the lines are parallel. So if I have these two lines here, M and N, and they're both hit by this transversal, if the alternate interior angles are congruent, aka 4 and 6, then that means that line M is parallel to N. So it's important for me to go back and forth between the two. If the angles are congruent, that means that the lines are parallel. If the lines are parallel, that means certain angles are congruent. All right, let's keep moving with this. Next one we're dealing with is alternate exterior angles. So this time we're focusing on 2 and 8 for our example. But if two lines, once again, and a transversal form alternate exterior angles that are congruent, then the lines are parallel. So if 2 and 8, they're both outside of our two lines, M and N, and they're on opposite sides of our transversal, if they're congruent, then that means that M and N are parallel. Now, in the same vein as these two, we've been dealing with if two lines and a transversal make a pair of congruent angles, then the lines are parallel. So the next one, same type of deal. If two lines and a transversal form this time corresponding angles that are congruent, then the lines are parallel. So if I have a set of corresponding angles that are congruent, so let's say 1 and 5, if those two are congruent, then line M is parallel to N. So same type of deal, same type of thing, we're just extending it further. So just like how we were doing with noticing that our angles are congruent, then our lines are parallel. For our next two, we're dealing with angles that are adding up to a certain thing. I hope you remember it from our last round of notes. So if two lines and a transversal form consecutive interior angles, remember those are the same as same side. Consecutive and same side, those are the same things. Now, if they form consecutive interior angles that are supplementary, then the lines are parallel. So, if our two consecutive interiors, 4 and 5, if they add up to 180, aka they're supplementary, then that means that M and N are parallel, just like our previous ones. So, if these two work, it's parallel. It's also the same type of deal if we got some exterior ones. So, if two lines and a transversal form consecutive exterior angles that are supplementary, then they are parallel. So 2 and 7, those are both consecutive, they're both exterior. If they add up to 180, then your lines M and N are parallel once again. All right, people. So that was a solid bit right there. Let's get a little bit of practice in here. So on our practice that we got here, we're looking at the right side of your paper. The bottom you're going to have to be hitting up on your own. So hopefully you use this to your advantage. So first one they want us to find the measure of angle A that would make these two parallel. So first off, we got to know what is the relationship between this angle here, 80, and A. They're both on the same side of the transversal, and they're both facing the same direction. The angle's pointing this way. Angle's pointing this way. Now, because of that, that makes these two corresponding angles. They're in the same part of the line on the matching corner. They're both facing the same way, not inside of each other like consecutive ones are. So, if that's the case, these two have to be both 80 for these lines to be parallel. Nice and easy. So, next one we're looking at what angle can A be for these two to be parallel. So if I look at 73 here, 73 and A, they're not an angle pair, but I do know something about another angle that's like 73. I do know something about this. This angle here next to A, it's 73. They're both corresponding. So if A and this angle here, which would be 73, if these two are going to add up to a straight line, A would have to be 107 for these two lines to be parallel. So if the angles are different, just like I said last lesson, if the angles are different, they're going to be adding up to 180. So A here and 73, they're different. They're not an angle pair that's associated with each other, so that means that these two need to add up to 180. All right, next one we got. We got angle A and we got 134. What could make these two make the lines parallel? This is a smaller angle than this, and they're both on the same side of the transversal and outside of our two lines. That makes them consecutive exterior. For these two to make us have parallel lines, A's got to add up with 134 to make 180, which is going to make it 46. Now for our last one, we got what angle could make what angle could A be to make these two parallel? I don't know of a pair that 112 and A are, but I do know that they're both outside of our two lines off the top of my head. And it looks like they're on different sides of the transversal, which makes these two alternate exterior. So I had to think about it a little bit before we jumped in. If they're alternate exterior, for them to be making parallel lines, they got to be congruent. So that means that A has got to be 112 also. Now, on the bottom, you got a couple more just like this. So make sure that you go through, hit those couple up, and then get it glued into your book. I'll see you on the flippity flip. Have a good night.